what is this binary search? What is this binary search? Mainly, binary search is nothing but searching the items. Okay, searching the items in a sorted array. This is very, very important. The array should be sorted for binary search. If the array is not sorted, binary search is not possible. Okay, this is very, very important. The array should be sorted. That is the array, whatever the elements you give to take an array. For example, look here. There is an example over here, 10, 20, 30, 40, 50, 60. This is nothing but the items present here are sorted. Sorted means what? They are either in ascending order or either in descending order. That is very, very important. Sorted means the number should be in order. They should be in perfect order. If you don't have perfect order, we cannot do this binary search. Okay, this is very, very important. Keep it in your mind. Binary search is sorting the items in a sorted array. This is very important. What do you do in binary search? List of items will give. For example, I'll take a simple array 10, 20, 30, and I'll give you a key element. That is, we will take this key element as an item to be searched. This is known as searching. Which item to be searched? That is known as key item. Okay. So what I do, I'll give this as 20. I'll give a key element as 20. What we do is, we will take this an array and we will search for an item present in this array. Okay. So just looking at this, you can tell yes, 20 is there, and you can tell 20 is there in the array, and you can write it as yes, the search is successful. But how do you do this binary search? Okay, you people already know this. We will divide the item into what? We will divide the array into two parts. That is, we will take 0, 1, 2. That is, these will be the, either you can take it as 1, 2, 3, or you can take the, what is this? Indexing as from 0 anything. We will take higher element and low, that is low and high. And what we will do you remember? We will find out the middle element. Mid equals to low plus high divided by 2. Right? So we will take the middle element and we will find the middle element first. This is what we do in binary search. Okay. So now 0 plus 2 divided by 2. 0 plus 2 divided by 2. So 1. So 1 is the middle element. This will be the middle element, right? This is what we do in our iterative search. This is very, very important. These are the steps we follow in binary search. Okay. To search an item, what we do first, we will take down low item, high item. We will find out the middle element. Middle element is equal to low plus high divided by 2. Then what we do? We will do this method. Look here. First, we have to see this method. This is very important. Low less than or equals to high. Why? Because always see to that this low less than or equals to high, because it is in ascending order, and low less than or equals to high is used to see whether the elements are there in the binary search. That is, elements are there in an array or not. If low is not less than or equals to high, you cannot search. That is, items cannot be searched. That is a condition we use in our iterative method. This is very important condition. After that, what we do, we will go with this mid equals to low plus high divided by 2. Okay. So now we will divide an item, and after the dividing an item, we will, what we do, very important thing, we will search the item. That is, if the item is less than middle element, if the item is less than middle element, if key is less than middle element, search in left hand side. Search at the left hand side. If key is greater than middle element, search in the right hand part. Do you remember this? What we do in our binary search? I want answers from you.
Yes, ma'am.
This is what we do. So to search the item, what we do? Key is less than middle element. What we do? We will do this. Look here. This one. What we will do? Low will be same. Low will be 0 only. High will become what? High is equals to mid. If it is less than 1. Low will be same, high will be mid minus 1. Okay. On the right hand side, what will we do? What we will do? Low will become mid plus 1. High will be same. High will be same. N. This is what we do when we are doing a binary search algorithm. These are the steps you people have to remember. These are the same steps we write in this algorithm. Look here. This is an algorithm. This is iterative approach. Actually, why I am explaining you this iterative approach, even the divide and conquer technique is also based on the iterative approach only. Only one, some 2-3 sentences we will change, that's all. Only for that purpose, I will explain iterative approach first. Then we will go with the divide and conquer technique. Both are same. Only the thing is we will write functions over here. That's all. Okay. Look here. First, very important thing is binary search a, n, comma, x. What is this? A is an array. Here they are taking it from 1 to n. N is an size of an array. X is the key element. X is nothing but key element to be searched. Okay. So determine whether X is present, and if so, return J such that X equals to A of J. Else return 0. This is just a commenting statement. That's all. And this is non-decreasing order. That is, n should be in increasing order. Okay, that is what the meaning. Okay, now this is very important. Assign, very important thing. First we have to assign. Look here in this, whatever I have written here. Always low should be pointing to the first statement and high should be pointing at the last indexing of an array. That is what they have written. Low is equals to 1, high is equals to n. Why they have taken n? Because 1 and n, because in this approach, see in this example, they're starting it from 1 and n. So that is what they're taken. So low, first assign low and high. Okay, you are able to follow what I am writing here. This is what low and high. I think many people know this binary search. Low and high. Next, while low is less than or equals to high, check whether low is less than or equals to high, because the array should be there for me. If low is not less than or equals to high, it won't, array, that is elements won't be there in that. So I have to do this condition. Okay, first we will check this condition. If this condition is true, we will go with this. We will divide the array into 2 halves. We'll find out the middle element, and then after finding the middle element, I have to check whether the key element is less than middle element. If it is less than middle element, search in the left hand side of an array. Left hand side. If the key element is greater than, search in the right hand side of an array. Okay, finally keep on doing this. Repeat this. Then after this, if key element is find out at the left hand side of an array, we no need to go with this else part. Right? There is else over here. Look here. If this is true, don't go to the else. But if this is false, go to the right hand side. Then after going to the left hand side, what we'll do? We again will go back, repeat the same process again and again, till we meet the condition where all low, high and mid will be in the same position. Look here, this is very important. They all three will come to the same position. Finally, we will find out a key value. Okay. So when you go to the left hand side, only left hand part will be searched. Else you go to the right hand part, only right hand part will be searched. Okay. And other remaining elements will be left like that only, because I need to search the key element only in a proper position. That's all. If it is on the left hand part, leave the right hand side, so that time complexity will be saved for us. There won't be more time consuming. Okay, we will leave the right hand side. If the element is on the right hand side, we will leave the left hand side. And apply the same steps again from the beginning. Whatever you do this from here, again, repeat the same steps again and again. Okay. So now we will trace out this, how this algorithm is written, we will trace out. Look here, according to this example, X is nothing but key antartha. Okay. Key is equals to X, they are taken in this algorithm. Now key element is 40. Okay. Now low is equals to, what is this? Low is equals to 1, high is equals to n. That is, low is equals to 1, high is equals to 10. Okay, now this condition is checked. Now come to this condition. Low is less than or equals to high. Is 1 less than or equals to 10? Tell me the answer. Is 1 less than or equals to 10? The condition is true or false? The condition.
True, ma'am.
True, right? 1 is less than or equals to 10. The condition is true for me. Since the condition is true, now I will go into this condition. That is, I will enter the loop. Now, mid equals to low plus high divided by 2. What is mid? 1, that is low 1 plus 10 divided by 2. So middle is equals to 5 for me. Okay, so mid is now here. Middle element is 5. This is mid. Okay, mid equals to 5. So now this is the half. So this is first part. This is left hand side. This is right hand side for me now. Okay, middle element is equals to 5. Mid equals to 5. So that is equals to 5. That is, or you can take it as 50. Okay, now this condition is checked. Now come to this sentence. Check this condition. If key element is less than or equals to A of mid. What is key element for me? 40. Is 40 less than 50? I'll write those here. 40 less than 50. If the condition is true or false? Tell me the answer. Is 40 less than 50? This tracing is very important because they ask you this type of, they will give you this type of array and you have to trace it line by line and show it finally the keys element is present in the array or not. Okay, whatever it is, look here. 40 is less than 50. The condition is true. So since this condition is true, now we will take only left hand side. We will take only left and we will remove the right part. We will not go to this right part now. Why? Because my key element is 40 and 40 is less than the middle element. So I search only in right hand side. Search only in, sorry, left hand side. That is enough for me. Right hand side is left because I don't want right hand side because they are already in sorted. That is, they are in sorted array and these are all numbers which is greater than a key element. So I cannot find the key element over there. So do it here. Now look here. I will do only on the left hand side. Okay. Now I will not go to this else part. I will not go to else part. So this is my condition now. Look here. Yes. The condition is true. Then what I have to do? High is equals to mid minus 1. This is very, very important. Look here. Low will be same. Low is 1 only. I told you, when you, on the left hand side, low will be same. High will change. Right hand side, low will change. High will be same. So now low is 1 only and high is mid minus 1. What is mid? Mid equals to 5. So high is equals to 5 minus 1. That is what? 4. I will get 4. Okay. High is equals to 4 for me now. This is what tracing technique we have to do. High is equals to 4. Now, low is equals to 1. High is equals to 4. Again, go back. Repeat the same process. Now, low and high are changed. Come here. Low is less than or equals to high. 1 is less than or equals to 4. Yes, the condition is true. Come here. Low plus high divided by 2. Repeat this again and again. So, mid equals to what? Mid equals to 1 plus 4 divided by 2. That is 5 divided by 2. 5 divided by 2 is nothing but 2 point something we will get, right? So 2 point, since we are taking only integers, take it as 2. So mid is equals to 2 for me now. Mid equals to 2. So now on the left hand side of an array, this is the left hand side. I will search only in the left hand side. Now middle element is what? 2 for me. So mid is 2. Look here, mid is 2. So mid is 2. Okay, so what is that? Mid element is now for me is equals to 20. Mid element is 20. Now again, repeat the same process. Look here. If key is less than A of mid, then high equals to mid minus 1. What is key? Key is 40. So is 40 less than 20? Middle element is 20 for me. Is 40 less than 20? The condition is true or false? False. The condition is false. Now I will go to this else part. Now for me, this is an array. Now look here, I have only right hand of an array, that is I have 10, 20, 30, 40 and 50 is only array for me. I will be searching only in this item, in this thing. Now for me, what happens? This is a middle element for me now. This will be 0, 1, 2, 3, 4. This is now low. This is now high, and sorry, for example, I will take 1, 2, 3, 4, 5. And what is the middle element? Middle element is now, sorry, this is 3 now. Oh, 1 plus 4, 1 plus 5, right? Sorry, this is 5. High element is 5. Sorry, 5. So 6 divided by 2, it is 3. Okay, it is 3. So middle element is 3 for me. Okay, see, this is what middle element. Now, compare. Key 40 is less than 30. The condition is false. So now what I'll do? I'll search the item on the right hand side. Now I will do this on the right hand side. Okay, that process is repeating now. Again, I will come to this part now. So now what happens? Key is greater than A of mid. Yes, 40 is greater than 30. The condition is true. So now what happens? Low will be mid plus 1. High will be same. High is 5 only. Now low is what? Mid plus 1. Mid was 3. 3 plus 1, 4. So 3 plus 1 is 4. Low is now 4. Now again go back to this statement. Now the low and high are changed. Again come here. Low is less than or equals to high. 4 is less than or equals to 5. The condition is true. Again come here. Mid equals to low plus high divided with. Now search only in this part. Only in this part of the array. Don't search in this part. This is what we will be doing. Divide it into keep on doing. Okay. This is what I do. Now search in the right hand side. Now mid equals to 5 plus 4 divided by 3. So that is what? 5 plus 4. Sorry. Middle element is, what was the middle element previously? 5, 6, 7, 8, 9. 9 divided by 2. So finally what you will get? 4. Okay, 4.5 you will get something. So middle element is now 4 for me. Okay, mid is equals to 4. What is middle element 4 and what is item? It is 40. Now the item is 40. Okay, now this condition is checked. Now come here. X is less than or equals to A of mid. Is X less than A of mid? False. Is X greater than A of mid? False. So both conditions are false. Now what happens? Return mid. What is return? Mid. That is 40. I will write 40 over here. Return mid. So now I have written 40. That is what I will write 40 over here, and then finally you can write one more statement. It will come out of the loop, and 40, that is key element, is found. Okay, this is how we do the binary search. Okay, understood whatever I'm explaining? At the last point where low, high, somewhere we will get a point where mid will be pointing to the key element. Always at the end, mid will come to the key element part. Okay, so this was somewhere I did mistake. Lelo mistake madidini ಹೇಳ್ತೀರಾ ನನಗೆ. So second middle element was 1 plus 4. Low plus high. Middle element was minus 1 alva. Mid minus 1. Okay, sorry. Here it was mistake. 1 plus 4 by 2. That is correct. It was 2 only. It was 2. Okay. Really mistake ಆಯ್ತು. Whatever I'm doing, you people are just sitting quietly and listening. That's all. You people are not concentrating whatever I'm doing. So look here, after the second time, what I'll get this array, right? I'll get this 10, 20, 30, 40 I will get. Okay. This is 1, 2, 3, 4 I will get. Why? Because we have low and high is equals to mid minus 1. So I got this one high. So mid equals to what? I'll get mid over here. Mid was this. Okay, now again 40 is less than 20. Condition is false. So search in the right hand side of an array. Okay, now array is only 30 and 40. So now on the right hand side, what will be this thing? This will be low, mid plus 1, and this will be high. Okay, so this is what low equals to, what is mid? Mid was 2. So 2 plus 1 is, sorry, first we have to find, this is low, this is high. So now low is equals to mid plus 1, 3. High is equals to 4. Okay, 3 and 4. Okay, this is low and 4. Now again find out middle element, that is 3 plus 4 divided by 2. So this is 3 again I'll get. So look here. Now this is 3, this is 4, 5, 6, 7. 7 under 3 point. Okay, tell me the answer. Now it is 3. Now middle element is at 3, high is at 40. Okay, now is 40 is less than 30? No. Again the condition will go back. Now again you have to repeat this process again. Okay. Now again you have to repeat this process, and finally what I'll get only this array, and where all low, high and middle, all element, all will be pointing to the same location. Okay, this is what binary search, that finally all will be pointing to the same location, and then you will get the key element found. This is what binary search. Okay, Artha Aktiviya, Harish?
Ma'am.
So this is like our divide and conquer only. The thing is, here we are using iterative method. That is, we are using looping structures here. Okay, same procedure, whatever we do, we will follow the same procedure in our recursive approach. Look here, same procedure we will follow. Look here, mid equals to low plus high divided by 2. That is also same. If key is less than A of mid, okay, that is what low equals to, same thing, high will be mid minus 1. If it is greater than this, this is left hand side, this is right hand side. Same procedure is followed. Only thing is, we will be writing an algorithm recursively. Look here, this is array, I is indexing, that is we will start from, this is low, L is nothing but they are taking it as high, and X is nothing but a key element. Same thing, whatever you do iteratively, we will write in the form of recursive approach, that's all. Look here, and then this condition is very important for recursive approach. What is this condition? Look here, if low is equals to high, that is if you have only one element in an array, only one. Finally, we will get only one element, right? Look here at the last, what we got here. Finally, mid, high, everything was pointing to the same pointing. That is, they all were pointing only to the 40. That is, all were pointing to 4 indexing. That is what, that finally we will have only one element at the array. Finally, at last, we will have one element where low, high, middle element, all will be pointing to the same location. That is what here. That is a small piece of all the arrays. Finally, I will divide the array into I will divide array into small pieces so that finally I'll get only one piece, one small piece. So that is what, if small p, that is last small, that is when low is equals to high, if key is equals to a of 5, okay, then return 1. That is, key element is equals, look here, In this, for example, I have only 40 element. This is the low item. This is I. Only one element is there. That is low is equals to 1, high is equals to 1. Okay. Key element is 40. So look here, 40 is equals to A of I is 1. 40 is equals to 40. The condition is true. Return 1. The condition is true. That is, the element is found. If you have only one item in an array, this is taken recursively. Why? Because we have to put some stopping condition in our recursive statements, right? For that purpose, we will take this condition. Okay, like our min max and all for one item, for two item, for many items. Here also same thing, for one item, only one item is there in an array. This will be found. If more than one item in an array, what we have to do? We have to follow the same iterative approach. Mid equals to low plus high divided by 2. Then check whether key element is equals to mid. Look here, this is the condition, very, very important. In iterative method, we will write that at the end. Look here, return mid is at the last. But in our recursive approach, what we do is we will write middle before, that is in after this itself we will write this. If key is equals to A of mid, return mid. What is that? In the beginning itself, for example, 10, 20, 30 is a number. This is low, this is high, and key element is 20 for me now. Okay. Key element is 20. I will get middle is equals to 20, right? So middle will be 20. Now beginning itself, I have found the element and I no need to go to the left hand side and you need to go to the right hand side. Starting itself, I am telling that key is equals to mid so that I can save the time. This is what very, very important. To save the time, key is equals to A of mid is written here itself. In the beginning itself, we will check whether our middle element is equals to key element. That is what we do. Difference between iterative approach and normal this recursive approach. Okay. In here itself we will write mid. Then look here. Then we will write those two sentences here. That is what these two sentences are written later. This sentence. If key is less than A of mid, then high equals to mid minus 1. Key is greater than A of mid, then low is equals to mid plus 1. Whatever that then will be there, that is mid equals to low plus 1 and all, you have to write that in form of recursion. That is, you have to call the function. Look here, I'm calling the function. Here, if key is less than A of mid, what I do? Low will be same. Low will be 1 only. High will be what? Mid minus 1. Look here, same thing he is written here. Low is, they are taking it as I. They are taking low as I. Okay, A is same. Call the function with array. Low is same. High is mid minus 1 and key element. Call this. Go back. Call the function. Again, go back to this return state. That is, go back to this function. Again, do this. If only one element, you do this. If not, come to this condition. Divide it by 2. Then again check whether the middle element is equals to key element. If it is equal to key element, take here itself or else search here. Else come here. If it is true, return this. If it is false, return this. That's all. Keep on doing this again and again. But what we do is, we do it recursively. Understood? This is what recursive approach. Only the thing is we will be using binary search functions. Binary search, calling this function again and again, And this is the recursive approach. Steps are same like iterative only. Nowhere we are changing the steps. That is what this is also iterative conquer only. This is also divide and conquer technique only. Okay, so what we do here, I will take a list of array. I'll take this. I will divide this into two halves. left and right. I'll search whether the key element is on left hand side. Again, divide this into left and right. Again, keep on doing. That is known as divide. You're dividing into smaller pieces. Finally, I will get one solution at the last. Only one solution I will get. Okay. So divide, and finally that solution, whatever you get, that will be the answer for this. So this is known as divide and conquer. Understood? You're able to catch up whatever I'm telling? ಅರ್ಥ ಆಯ್ತಾ?
Yes, ma'am.
So any doubts, you can go through the notes whichever I have sent. Already the notes I have sent to you people. Same thing is there in the notes. Both types are there. That is, iterative approach is also there, recursive approach is also there. But in exam, they'll ask you only recursive approach. This algorithm is very, very important. Whatever I have showing now, this recursive approach is very, very important. Apart from this algorithm, now very, very important thing is we have to find out the efficiency, time complexity of the binary search algorithm. Okay, now we will go with that efficiency, that is time complexity of binary search algorithm. How to solve the time complexity? Very, very important question. Okay, I'll open that notes. There only I will just solve you and I will show you how we will get that. This is what any of the module we take. This is what we do. We will just trace the algorithm. We will find out the efficiency of that algorithm. That is what we will do in the DOP subject. Are you able to see the screen?
Yes, ma'am.
Okay, look here. This is what we have written in the notes. Same thing. What is binary search? Recursive binary search. This is what the algorithm I explained now. Recursively, with what we will be doing. This is iterative binary search. This is a normal ADA method, whatever we follow. And this is the very, very important thing. We have to analyze the binary search. Look here. Always binary search, we have very, very important thing in binary search. Always we can find out three important cases: best case, worst case, and average case can be found out for binary search. Why? Because I take an array. This is very important. For example, you take merge sort, we will find only worst case, or we will find the best case. Min max, I was finding only the best case for me, that's all. But here in binary, we will have all the three cases. That is worst, best, and average. Look here, I have list of elements. I can divide this into two parts: middle, left part, and right part, right? So when I get an key element is found in the beginning itself. When I get key is equals to mid, beginning itself I found the element is found in the array. That is, I no need to go to the left hand side and no need to go to the right hand side. In beginning itself I found, and I'll tell that that is the best case. That is the best answer for me. Okay. Look here. Best case occurs when we are searching the middle element. In that case, total number of comparisons is equals to 1. So the best case for me is 1. Best case is always represented like this, omega. So for me, for binary search, always best case is 1. And the beginning itself, we will get the output. That is the best case. Okay. So now, for example, somewhere the key element is on the left hand side or somewhere it on the right hand side. You have to do it again and again. Search on the left hand side, divide that into parts, again search the middle element, again keep looking until you get the small answer, right? So I cannot tell where the answer is. That is the worst case. Okay. So worst case T of time involved to search n number of elements. This is very, very, very important. Like min max, we have to find out the first relation, recurrence relation, then we have to solve this. You know, in min max also we found out recurrence relation T of n by 2 plus. You remember that recurrence relation in min max? Look here, this is what we did in min max. This was the recurrence relation. If two items were there, only one search is then only one time I need to compare. If only one item is there, no need to compare. And finally, if you have a number of items, this is the recurrence I, and where you have to stop the condition, that is here. When n is equals to 1, the condition is 1. You have to stop. You have to take that condition over here. So look here, k minus k, substitute I as k minus k 2 power 0, that is 1. So t of 1 is nothing but 1. Finally, I will get k. So this is what theta, or you can even take it as worst case big O, both are same. Okay, k, and look here, what is the value of